Okay, my co-authors are my PhD student, Estera Valean. She started research on studying the properties of the reinforced PLA with carbon fibers. And Pietro Foti, who is here, and Filippo Berto, because she was for a while to do some tests in Trondheim at the time where they were in NTNU. So a short summary. So I will talk very shortly about fuse deposition modeling. I will present our printing technology and the parameters that we use for print our specimens, experimental, static, and dynamic bending tests, and some conclusions. So, as you know, additive manufacturing is part of the industry 4.0. Talking about polymeric materials, we have different techniques which use different state of the material. First presentation in this session was about material jetting. The material was in a liquid form, the same like in photopolymerization. So we use material extrusion, which is probably one of the, let's say, easy to control and to customize additive manufacturing technique for polymeric materials, which reduce labor cost, which reduce the material waste, and has a quite shorter production time. Nowadays, this technique is used more and more in different industries. So up to now, there are some studies published regarding the tensile results on PLA and PLA reinforced with carbon fiber. So we did some tests on tensile tests, and what we get, higher strength, but what we also get, higher modulus, tensile modulus of the PLA comparing with PLA reinforced with carbon fiber. I was looking on the literature, and there are other authors which get the same results. So on tensile strength tests, some of my colleagues from Timișoara, they investigate PLA reinforced with glass fiber, with carbon fiber, and with bronze particles. And the maximum tensile strength they also was obtained for the PLA. And also there are a recent study in press from some researchers from India. They also studied PLA, ABS, and nylon reinforced with carbon fibers, and they get higher tensile strength for unreinforced PLA, also flexural strength, but they get higher tensile modulus and higher flexural modulus for their tests. So we use a commercial 3D printer made by Czech producer, a Prusa printer. PLA and PLA reinforced with carbon fibers, less than 20%. The dimension of the fibers were the medium diameter was between 10 and 15 microns, and the length of them was around 250 microns. We print because we want to do impact tests. We choose the shape of the specimen according with the ISO 179, which is the instrumented impact recommendation. So we use rectilinear pattern, plus minus 45 degrees, the infill angle, 100% infill, nozzle diameter 0.4. The heated bed was at 60 degrees Celsius, and the extruder temperature 215 Celsius. And we use some contours around the edges of the specimen. So the static tests, we did it in our lab with using a 3-roll universal testing machine at room temperature with a loading speed of 2 millimeters per minute, and we use 6 specimens, notched and unnotched, for each type of of material. For the dynamic test, we use also an instrumented impact hammer, instrument chest, which is also in our lab. We used room temperature. We did the test at room temperature. The potential energy of the hammer is 5 joules. And the initial angle for the calculating the potential energy was 150 degrees. Also, 6 specimens for each material notch and unnotch we use. So some results for the static test, we got the same results as in the case of tensile test. So the higher strength was obtained for the PLA comparing with PLA reinforced. The only difference, and let's say property which is higher for the reinforced PLA is the energy of fracture, the area between the curve, which is higher in both cases in unnotched and also in the notched specimens. So we determine the flexural modulus. There are not so big differences in flexural modulus. So it's around 1.76 gigapascal for PLA and 1.68 gigapascal for PLA reinforced with carbon fiber. We determine the stress at break, the flexural strength for all the materials. So the highest value, as you can see, more than 105 megapascal is for the PLA, and then we have the value for the PLA reinforced with carbon fiber, which is around 80. The energy absorption is the only property that is higher for the reinforced specimens for both notched and unnotched specimens. So we try to estimate the fracture toughness on this static test. So what I did a calibration of this specimen because this is not according with the ASTM standard for fracture toughness of polymeric material. So we did a very simple finite element analysis. And for this ratio between crack length and width of the specimens, which was 0.2 for these specimens, we get this non-dimensional selectivity factor of 7.09. And I compare with our other results, which are related the fracture toughness determined according with the ASTM standard. So we get quite similar results. For the PLA reinforced with carbon fiber, almost the same results. And for the other, a little bit higher values, but not so much. So inspired by presentation of yesterday of Francesco Iacoviello, I would like to check what ChatGPT gives for these materials. And you can see, asking for the fracture toughness of PLA, simple PLA, I got 2 megapascal square meter. Defining more, PLA 100% in fill and with contours, the result of the ChatGPT is 4 megapascal square meter, quite close to what we get experimentally. Also for the reinforced material was give us 2.5 and the test result is 2.9. I don't know. Maybe in future the predictions will be better. However, on my opinion, we should stick to perform some tests. So some results from the impact test. We have here the impact force versus deflection and the impact energy. On this case, impact strength also for the reinforced PLA are lower than those which are testing only on PLA specimens. The total energy absorption comparison between static and dynamic results. So I mentioned on static results we have higher energy absorption for the reinforced PLA. On the case of the on the dynamic load, so these are not the same, so are lower values. So we want to see a little bit why the results are, because we expect to have better results for the reinforcement specimen, at least for the modulus of elasticity. And so looking on the micrograph of reinforced PLA, we can see around the fibers there are some pores. So the interlayer structure. So there is not perfect bond on all the fibers, and this is probably due to the compatibility of the PLA and maybe could be also due to our process parameters, fabrication parameters. We keep the same parameters for PLA and PLA reinforced with carbon fibers. So to conclude, so the only improvement that we obtained adding the carbon fiber was for the fracture energy, which was higher on static tests, not on dynamic tests. So I think I thank you very much for your attention.